This is the 4.4 Day 2 video for notes. On Day 1 we talked about parallel lines and we learned that parallel lines have the same slope and different y-intercepts. On Day 2 we're focusing on perpendicular lines. So remember, perpendicular lines are two lines that intersect to form a right angle. And what you guys should know is that what makes that happen is that they have opposite reciprocal slopes. Opposite means you change the sign. Reciprocal means you flip the slope. For example, if we have a line with a slope, let's say, of 1/2. If I'm trying to make a line that is perpendicular to that, I'm going to change the sign, so the opposite of positive would be negative, and then the reciprocal means that you're going to rewrite it flipped upside down, like that. So these two slopes are opposite reciprocals. They're opposite because one is positive and one is negative, and they're reciprocals because I've taken this one and flipped it. So the reciprocal of 1/2 is 2, or 2 over 1. Okay? So let's kind of look at how we would use that. So here it says to determine which of the lines, if any, are parallel or perpendicular. So in order to do that, I need to actually compare their slopes. So if you look at line A, which I'm going to write line A's slope in red, line A is easy because it's written in slope-intercept form, and I can see that line A's slope, so line A, has a slope of 4, because that's the number in front of x. In slope-intercept form, it's y equals mx plus b, and m is my slope. Now when I look at line B, I notice that it's written in standard form, so I need to solve for y before I can look at the slope. So the first thing I'm going to do is I'm going to subtract x from both sides, because I'm trying to isolate y. So that's going to give me 4y equals negative x plus 3. Then, in order to get y alone, I'm going to divide everything by 4. Now when I do that, what I notice is that I have y equals, and that says negative x over 4. So that's like negative 1x, so it's negative 1/4 x, and then I have that plus 3/4. So for line B, I notice that my slope is negative 1/4. Okay? Then I'm going to go ahead and deal with line C before I start comparing the slopes. So the first thing I'm going to do is add 2x to both sides because I'm trying to get y by itself again. And the reason I'm trying to get y by itself is because in slope-intercept form I can actually see my slope. So in standard form I can't. So I am dividing everything by negative 8 at this point to get y by itself. 2 over negative 8 is going to reduce to negative 1/4 x, and 16 divided by negative 8 is negative 2. So now I have line C with a slope of negative 1/4. So it's easy to identify the lines that are parallel because parallel lines have the same slope. We learned that on day 1. So notice that line B and C both have a slope of negative 1/4. So I know that line B is parallel to line C. Now, let's talk about that perpendicular. So remember, perpendicular lines have opposite reciprocal slopes. So notice that line A has a positive slope, while line B and C have negative slopes. So they are opposites. Then I need to decide, well, is 4 the reciprocal of 1/4? So remember, reciprocal just means that you flip this slope upside down. So I know that line B and C are opposite reciprocals of line A, which means they must be perpendicular. So line B and C are perpendicular to line A. And that would be the relationship between the three lines. Now, just like on day 1, the next thing that they're asking you to do is to write the equation of a line given some information. So they're saying to write an equation of the line that passes through negative 3, 1 and is perpendicular to the line 1/2 x plus 3. So what they've done here is they've given me a point, so I'm going to go ahead and label that x1, y1 like I always do. But this time, since I want a line that is perpendicular, I don't want to use the same slope, I want to use the opposite reciprocal slope. So this slope is positive, so the opposite of that would be negative. And then since this slope is a half, the reciprocal would be 2 over 1. Now when I use that in point slope, because now I notice that I have a point and I have slope and I'm trying to write an equation, so that's why I'm using point slope, I'm just going to write the slope as -2 in my formula. Okay, so point slope is y minus y1, which in this case is 1, equals your slope, which is -2, times x minus x1, which in this case was -3. Now remember, the reason we're using -2 as the slope is because if it's perpendicular, it's opposite, which means it has a different sign. So this was positive, this one's negative, and it's the reciprocal. And the reciprocal of a half is 2 over 1, which is just 2. Okay? So just like when we were using point slope before, I want to go ahead and turn this into slope-intercept form. So I'm going to distribute my -2. And I'm going to add 1 to both sides in order to get y alone. So that will give me y equals -2x minus 5. Now, I know that these lines are perpendicular because if I look at their slopes, they're opposite reciprocal slopes. So that means if I was to graph y equals half x plus 3 and y equals -2x minus 5, they would intersect to form a right angle. The last thing that we talked about on day 2 was parallel and perpendicular lines and how they relate to vertical and horizontal lines. So here it says to write an equation of a line that is parallel to the x-axis and an equation of the line that would be perpendicular to the x-axis. And then they ask you what the slope of each line would be. So when I taught you guys this, my suggestion was to go ahead and draw a coordinate plane. And then that way you could sketch a line and kind of look at it in order to write the equation. So remember, your x-axis is your horizontal axis and your y-axis is your vertical axis. If I want to write a line that would be parallel to the x-axis, that means it needs to be a line that is horizontal. Okay, so I've drawn a green line that is parallel to the x-axis. Now, since I'm writing an equation, remember when I taught you guys to write equations of horizontal and vertical lines, I said horizontal lines. I gave you the acronym HOI. So remember, horizontal lines have 0 slope and their y equals a number. So I'm just going to approximate. I'm going to just say that this line is crossing the y-axis at +3. Okay, so that would make the equation of that line y equals 3. Now in the problem up here, it also asks you for the slope, and remember, this helps you remember that a horizontal line has 0 slope. So that line is parallel to the x-axis. Now they've also asked you to write one that would be perpendicular to the x-axis. Well, a perpendicular line, perpendicular to a horizontal line, would be a vertical line. So I've drawn a vertical line here. Notice these intersect at a right angle. So remember I taught you the acronym VUX for vertical lines. That stands for vertical lines have undefined slope and their x equals a number. So we know that x equals, and then I'm just going to approximate this that it's crossing at -4. So x equals -4 would be perpendicular to the x-axis, and it has undefined slope. Now remember, they just asked us to write an equation, so I got to choose any, line that I wanted. I just had to make sure that parallel to x would also be another horizontal line, and vertical would be perpendicular to the x-axis. So these points where I chose for those to cross, it doesn't have to cross here. It could cross, below, it could have been over here, just as long as you're paying attention to the fact that the x-axis is a horizontal line, so another horizontal line would be parallel to it, and then in order to be perpendicular, you have to have a vertical line. Okay? All right, so that winds up closing out our lesson for today. So 4.4 we did 2 days on. We did day 1 and day 2. We focused on parallel lines on day 1. We added in perpendicular lines on day 2. And if you guys have any questions, then please come in for tutoring. Have a great night.